Hello everyone, myself Sunil Kumar from Sri Venkateshwara College of Engineering from the Department of Computer Science and Engineering. Today we are going to study about the Lex and yaac program. Before going to complete Lex and yaac program, let us brief about the Lex program. Lex and yaac program helps you to write programs that transforms the structured input. Coming on to Lex program generates C code for lexical analyzer, whereas yaac generates code for syntax analyzer. Lexical analyzer is built using a tool called Lex. Input is given to Lex and lexical analyzer is generated. Lex is a Unix utility. It is a program generator designed for lexical processing of character input streams. Lex generates C code for lexical analyzer. Lex is used the patterns that match strings in the input and converts the strings to token. Lex helps you by taking a set of descriptions of possible tokens and producing a C routine, which we call a lexical analyzer. The token descriptions that Lex uses are known as regular expressions. Coming on to the structure of the Lex program basically consists of three sets. One is definition, rules, and user subroutines. Coming on to how to write the Lex program. Step 1. By using the gedit, create a file with extension .l, for example program1.l, and step 2 lex program1.l, which gives the output, and the third step cc lex.yy.c slash ll, which this command creates the C routine, and dot slash a dot out gives the output. Coming on to introduction of yaac program. Yaac is a tool that generates parsers which analyze the structure of the input text according to a grammar. It takes a formal grammar specification and generates a parser that can recognize whether the input text addresses to the grammar. yaac uses a technique called LALR, look ahead, left to right parsing. It analyzes the grammar specification to construct a parsing table which is used to guide the parsing process. yaac also supports the use of semantic actions, which are code snippets executed during the parsing process. The input to yaac is a file containing a grammar specification. The grammar defines the syntax and structure of the language being processed. It consists of a set of rules that describe how different elements of the language can be combined. Each rule consists of a non-terminal symbol and a sequence of symbols that can be derived from it. How the Lex and yaac program are integrated to get a single output. Lex and yaac are often used together to build language processors as seen before. Lex is used to generate the lexical analyzer, which breaks the input text into tokens. yaac then uses the tokens produced by the Lex to parse the input according to the grammar specification. The typical workflow for using Lex and yaac involves the following steps. Writing a Lex specification file .l or .lex file containing regular expressions and associated actions for tokenizing the input. Step B. Running Lex on the specification file to generate a C source file lex.yy.c. This is a command that implements the lexical analyzer. Writing a yaac specification file, we should write the yaac file with .y file extension containing the grammar rules and associated actions for parsing the input. Coming on to running yaac on the specification file to generate a C source file y.tab.c, which creates a C file that implements the parser, compiling the generated lex and yaac source files along with any other required code to create an executable program. The generated lex and yaac code can be customized to perform various tasks such as building symbol tables, generating intermediate representations, or executing actions based on the recognized syntax. Overall, Lex and yaac provide a powerful and flexible framework for developing compilers, interpreters, and other language processing tools. They automate many of the repetitive tasks involved in building language processors, allowing the developers to focus on the high-level aspects of language design and implementation. Some of the functions used in Lex and yaac program are YYLex. This function is automatically generated by Lex and serves the entry point for lexical analyzer. It reads the input characters, matches patterns defined in the Lex rules, and executes associated actions via text function. It is a character array that contains the matched text or token currently being processed by the lexical analyzer. Viva text always used within the action code to access and manipulate the matched text, YY and YY out. These variables represent the input and output streams for Lex. YY is the input stream from which Lex reads characters, and YY out is the output stream where Lex writes its generated output. They are typically initialized to std in and standard out respectively. YY function. This function is called by Lex when it reaches the end of the input. It allows you to specify custom logic for handling end of file conditions. By default, YY wraps return 1 to indicate an end of the input, but you can override it to implement additional behaviors. YY line number. It is an integer variable that keeps track of current line number being processed by the lexical analyzer. It can be used to report line numbers in the error messages or for other debugging processes. A simple example for Lex and yaac program to print the Fibonacci series. As, dis- as discussed, lexer.l, which means the Lex program. The Lex program consists of definition section, rules section, and subroutines. The definition sections, which gives a definition hash include y.tab.h. The rules section basically consists of regular expressions. And coming on to the parser, parser means the yaac program, which is saved with .y file extension. Hash include stdio.h is a library. Yylex is the function. YY error is also a function. Tokens which are generated from the Lex program are taken. As it comes to the Fibonacci series, the left numbers are increased using this program. Yeah. The C code for Fibonacci series, which starts from int a is equals to 0, giving the variables, and print the variables. On getting all the commands, we get the Fibonacci series of 6 as 0, 1, 1, 2, 3, 5, 8. Thank you.